All right, this is Module 1, Lesson 6. We're going to be talking about negative exponents today. It's the last thing that we have to talk about in this module. All right, so the first thing is another discovery activity. It says complete the following charts using your calculator. To enter a power, remember you're going to hit that little caret symbol right here. That's for the exponent, and then you're going to hit enter. And then to change a decimal to a fraction, you're going to hit the decimal, or enter the decimal, hit the second key, hit the PRB key, which is fraction to decimal in blue, and then hit enter. I'm going to take you through a couple of these just so that you know what you're doing with the calculator, and then you can try it on your own. So let's look at 2 to the third. Just practice entering the calculator. Ready? 2 to the third, then hit enter. That would be 8. Obviously, 8 is a whole number. You just put 8 over 1. All right. 2 to the second power is 4. Put 4 over 1. Obviously, 2 to the first is 2. 2 over 1. 2 to the 0 is 1, so 1 over 1. So let's go to these. We have 2 to the negative first. When you do that, you get 0.5, but I want it in fraction form. So you're going to hit second, PRB, which then says fraction to decimal, and you're going to hit enter, which is 1/2. You're going to do that for the rest of these, and please go on to the next chart. Do that for both charts, entering them from your calculator. All right, so 2 to the negative second is 0.25. Second PRB is 1/4. 2 to the negative 3 is 0.125. Second PRB is 1/8. All right, I'm going to do that over here. Make sure you have parentheses around these because that does make a difference. Negative 3 to the negative 1 is negative 0.3 repeating. Second PRB, that's going to be negative 1/3. All right, negative 3 to the negative 2 is 0.1 repeating. Second PRB gives us 1/9. And negative 3 to the negative third power is negative 0.037 repeating. Second PRB gives us negative 1 over 27. So here's our chart. So what do you notice about these negative exponents? All the ones that we filled in, what do you notice? Do you notice that they're decimals? Do you notice that they can be written as fractions? Did you notice that the fractions are the opposites of the positive? Look at 2 to the negative first, 2 to the first. This is 2 over 1. This is 1 over 2. 2 to the negative second, 2 to the second. 4 over 1, 1 over 4. 8 over 1, 1 over 8. Did you know the fractions are reciprocals of each other? So I'm going to put just a little example here. 2 to the third was 8 over 1, and 2 to the negative third was 1 over 8. So they are reciprocals of each other. So what should 3 to the negative fifth mean? Or what should 3 to the fifth times 3 to the negative fifth mean? Let's focus on this 3 to the fifth times 3 to the negative fifth. If I take 3 to the fifth and I multiply by 3 to the negative fifth, if I use my rules, that would be 5 plus negative 5, or 3 to the 0. We know that is 1. Let me show you what you could also do to make this comparison. 3 to the fifth times 3 to the negative fifth. Now, remember, that's just the reciprocal of 3 to the fifth. That means that instead of putting this over 1, I put 1 over 3 to the fifth. Notice that when I make that reciprocal change, that exponent becomes positive. 3 to the fifth times 1 is 3 to the fifth. 1 times 3 to the fifth is 3 to the fifth. When I do that, I get 3 to the 0 or 1. Notice it doesn't matter if you add the exponents or if you actually change it to a positive value and then multiply. So what does this say about 3 to the negative fifth? That says that 3 to the negative fifth must be a fraction. And then specifically, specifically, I want to write the reciprocal of 3 to the 5th. So 3 to the negative 5th is the reciprocal of 3 to the 5th. So let's do some more practice. So negative exponents are always equal to a fraction. More specifically, the reciprocal of the positive value. I should probably spell this right. Reciprocal. So the benefit of having negative exponents, we can complete this in expanded form to show you. All right. So for example, the complete expanded form of this number is 3 times 10 to the second. This is what we did yesterday. 300, so it's 3 times 10 to the second. 20 is 2 times 10 to the first. 8 is 8 times 10 to the 0. Now we're going to have decimals. Okay, so 5 is in the tenths place value, which is 5 times 10 to the negative first. 4 is 4 times 10 to the negative second. 0 times 10 to the negative third. And 3 times 10 to the negative fourth. So those negative exponents are going to be the expanded form of a decimal. So let's do this one on our own. Push pause, and when you are done, make sure that you check your answer. All right, so 4 is the whole number. So 4 times 10 to the 0 plus 7 times 10 to the negative first plus 2 times 10 to the negative second plus 8 times 10 to the negative third. Now remember, this actually means 1 over 10 to the first. So that's the tenths place value. This actually means 1 over 10 to the second. It's the reciprocal, or the hundredths place value. This actually means 1 over 10 to the third, or the thousandths place value. That's where that comes from. So let me show you how to actually write or find negative exponents. Step 1, you're going to take the reciprocal of the base. You're going to change the exponent to a positive. A lot of people forget to do that. And then you're going to find the value. So here's an example. If we know the positive exponent, all we have to do is actually take the answer of it and flip it. So 6 squared we know is 36. So 6 to the negative second, we're just going to take the reciprocal. That's really over 1. The reciprocal is 1 over 36. So that's how you would do that one. So what is the value of 3 times 10 to the negative second? Well, this would be 3 times, take the reciprocal of this, so 1 over 10 squared, make it a positive exponent. That would be 3 over 1, or 3 times 1 over 100. 3 over 1 times 1 over 100 is 3 100ths. And 3 100ths looks like this. All right, let's keep practicing this. All right, so for exercises 2 through 9, you're going to write an expression using an exponential notation to one given and simplify as much as possible. I'm going to remind you when you're doing these, you always should have positive exponents when it comes down to the actual final answer. Okay, so exercise 2. I want you to try this one on your own. Hit play when you're done. All right, so this one is 3 times 1 over 10 to the 5th, which is actually 3 times 1 over, that's 4 zeros, 5 zeros. Put that over 1. So 3 over 100,000, which means that 100,000 would be like that. All right, exercise 3. We're going to take all these negative exponents, we're going to make them positive. So the negative 4s over 1, this is a negative exponent, which tells me to take the reciprocal. So negative 4 make the exponent positive. So this would be 1 over negative 4 to the third. This one already is a positive exponent. They just want to know what that is. If the 8 to the 9th is on the bottom, you're just going to flip it up to the top. But once you flip it, it becomes negative. All right, next one. We should probably know that this says 3 times 10, 2 to the negative 4th. Make sure you write that. The whole punch kind of cut that off. All right, so this is 3 times, remember it's a negative exponent, so flip it, 1 over 2 to the 4th. Make sure you make that exponent positive. So 3 over 1, so that'd be 3 over 2 to the 4th power. Exponent's positive, so that's our final answer. All right, exponent's negative, so we're going to take the reciprocal, 1 over x to the third. Exponent's positive, so we're good. Next one, okay, now let's start applying our rules. We have 19 to the second over 19 to the fifth. Same base, we're going to subtract. Now, I'm actually going to ask you to show me the subtraction because we're starting to get into negative exponents, and I want to make sure that you show me your work on these. So 2 minus 5 is 19 to the negative third. Now, you can't leave it like this because it's a negative exponent, but what we know about negative exponents is that we would take the reciprocal and make the exponent positive. All right, exercise 8. Notice the negative 4 is only on the y, not on the x. So the x is this is really like saying x times y to the negative 4th. So the x is just going to stay, but we're going to take the reciprocal of y to the negative 4th, make it 1 over y to the 4th. Now this is over 1, so we have x over y to the 4th. That is our final answer. Exponents are positive, so this would be our answer. All right, so dividing same base, we're going to subtract the exponents. So 16 minus negative 3. Now just a couple of reminders about when you are subtracting. You can do leave, change, change. You can also do this in your calculator. So 16 plus 3 is 19. Now that already is a positive exponent, so we can leave it like that. Now, one of the other things that I want to point out, and just so you notice, that when you have negative exponents, what you're basically doing is flipping it over the line. So if it's on the top, it goes to the bottom. If it's on the bottom, it goes to the top. So a lot of these, we were just making them go to the bottom. So y to the negative 4th, y goes to the 4th, goes on the bottom. 19 to the negative 3rd goes to the bottom. But just keep that in mind when you're working on these. This homework is kind of tough. I really want you to try the best that you can, and we will go over all of these answers when I come back tomorrow to class. Good luck.